So hello everyone to the November's reading group. Today we have Penny and she will be presenting a sociology paper showing that other departments also do great and innovative work. And yeah, I hand it over to you, Penny.
Thanks very much, David. And yeah, it's really great to have the opportunity to present and discuss this paper. As I mentioned before, I'm certainly not a sociologist, but this methodologies in this paper in particular is proving quite useful for some of the work that I'm doing in a project with Simon and Laura and another collaborator, Ling Fei Wu from the University of Pittsburgh, which is applying word embedding models to look at text data on patents and products and professions. And I look forward to sharing a bit more about that project with you at some stage. But in terms of the structure of this presentation, what I thought I'd do is firstly spend a little bit of time up front just talking through kind of a bit of conceptual background behind word embedding models, and then delving into the paper's key methodology, its validation strategies, and its key results. So feel free, as usual, to stop me at any point in time with questions, or if I haven't explained something as clearly as I could. And given the title, I hope you don't mind. I had a little bit of fun with this, riffing off the theme of the geometry of culture, and decided to decorate my slides with a bit of geometric art. So if you don't like Kandinsky, I do apologize in advance. But okay, so let me start with the word posh. How might we describe what is meant by the word posh? It's one of these words that is kind of like interesting to think about, and the more you think about it, the weirder it sort of sounds. But one way to conceptualize posh is a sort of like associated with the word style or fashion, which is sort of more closely related perhaps to the word rich or wealth. And rich or wealth in turn get their sense of meaning perhaps from being distant to a word's cheap or plain. When thinking about the word posh, some of us may also consider it to have slightly more feminine connotations, and feminine gets its meaning, if you like, from being to some extent on the opposite spectrum of the word masculine. And this sort of musing kind of highlights that meaning in a sense is quite relational. Meaning can also change through time. So for example, if you take the word gay, this used to be quite closely associated with the word cheerful or frolicsome, which gets their sort of sense of meanings from being quite distant from the word like sad or miserable. But as we know, over time, the word gay has sort of transformed to become much more closely related with words like homosexual, which we can also think about being at one end of a spectrum to a word, say, heterosexual or straight. And so a key question which this paper really speaks to is about how we can analyze this sort of meaning or conceptualizing meaning quantitatively. And one way to do this is through an approach that I'll spend a bit of time talking about today called word embedding. So the basic idea behind word embedding is nicely summarized by this phrase that you've no doubt seen many times before, that you shall know a word by the company that it keeps. That is, if you look at other words that a given word tends to be close to, and this could be in text data associated with books or articles or web pages or whatever, you often get a pretty good sense of what a word means by looking at sort of surrounding context words. What's more, if you look at the distribution of words, and if you have a way of analyzing this distribution over different contexts, the key hypothesis underlying this methodology is that words with similar distributions have similar meanings. So to give you an example, if you consider the following text, you know, it was really cold yesterday, it'll be really warm tomorrow, it'll be really hot, sorry, it'll be really warm today though, it'll be really hot tomorrow, will it be really cool Tuesday? What you can immediately see is that according to the distributional hypothesis, the words cold, warm, hot, cool are likely to be related in some way because they sort of occur in a similar context. So here they occur between the word really and a word relating to a particular day. Similarly, the words yesterday, today, tomorrow, Tuesday are also likely to be related because similarly they appear on the same kind of context. And so this suggests that a useful way to represent words is actually just through a big list of all the contexts that words occur in, which we can capture through something like this matrix here, a word to context matrix, where we're just listing all the words in a given corpus that, all the context in a given corpus that our word appears in. Now, if the distributional hypothesis is true, we do expect that words that share the same context to be closer in meaning, and this is something that we can test through this approach. The problem, of course, is that this word to context matrix is likely to be very big, very sparse. Depending on your corpus, you can have, you know, a number of contexts approaching millions, maybe more. So what we really want to do is reduce the dimensionality of this matrix onto a smaller number of k dimensions that best preserve the distribution of words over the various contexts in our text. So there are a number of different ways to do this, but the approach that is used by this paper is the very widely used algorithm known as word tovec.
Can I ask you something quickly?
Sure.
So words and context, so like behind this, so the idea is that these have like an infinite support. And so when you say that you want to reduce the dimensionality of the problem, what's the starting point is that both two dimensions have an infinite support and you want to make this infinite support finite? Or you start from the fact that this is I mean, the idea behind is that you start from some finite support, but this is still too large and you want to make this, you know, like countable, for example, like much smaller. So like, how do we need to think about this in that specific slide from like one slide before, this thing about words and context in terms of reducing the dimensionality as an objective?
Sorry, so just so I understand what you, when you say support, infinite support.
Yeah, like for example, you know, income is the support is the R plus, like is the real numbers in like in the positive space,
right,
like
right, sure.
like in terms, yeah, like support meaning yes, like mathematical support.
Yeah, so I think if I understand you correctly, I mean, this is certainly a countable number of contexts.
In this example.
Yes, but what we're saying is really, well, in general, I think it's still probably countable, but it would be very, very large. I mean, it would depend on your corpus. So generally to kind of find these contexts, we have a sliding window of a given number of words. So maybe it's a window of 5 words, and we slide that along our text. So in that sense, if you define it in that way, it will be a countable number once you sort of slid the window over the end of your corpus. But even doing that still gives you a very large number. And so we will like to reduce the dimensionality onto something a bit more manageable. Often, as we'll talk about later, 300 dimensions seems to be the thing that is used. It's a bit of rule of thumb. It really just depends on your corpus and the nature of the text that you're trying to analyze. But yeah, good question. So let me spend a bit of time briefly talking about word tovec. Word tovec is a technique developed not too long ago, but in some sense a long time ago in kind of machine learning time, back in 2013 by Thomas Mikolov and some researchers at Google. And it's essentially a neural network that can use one of two different architectures to produce a distributed representation of words. One is called continuous bag of words model, which essentially tries to predict a given word based on its surrounding context words. So, for example, if you have the words "a cat" directly before it and "on a" directly after it, what you're trying to do is learn the weights such that you can correctly predict the word "sat." The other architecture is called the skipgram model, which here instead we're trying to actually take a given word, so "sat," and predict the surrounding words. Now, both these archetypes have been shown to perform relatively well, but both have pros and cons. So the continuous bag of words is computationally faster, but according to Mikhailov, it tends to have better representations for more frequent words, whereas the skipgram model has better representations for more rare words, and also performs a bit better if you have a smaller amount of data. But essentially, by training these models using a corpus of text data and the sliding window that I mentioned to generate training examples, what we end up with are weights that characterizing our embedding or vector space to represent our words. So what is a vector space? Well, I'm going to use an example that Simon often mentions, which I really like, which is consider the case where we've just got a two-dimensional vector space, which we can think about a little bit like a two-dimensional map. So on a 2D map, you know that you can represent the location of something according to its Latin long coordinates. And essentially, the word2vec algorithm is trying to learn these coordinates such that it's going to place words that appear in similar contexts close together on this 2D map, and words that appear in different contexts far apart. Now, based on these coordinates that we learn, we can also analyze how close any word is to any other word in our embedding space. So, for example, if you know the coordinates for the word wealth and rich, you can calculate how close these words are in two-dimensional space by looking at what's known as the cosine similarity. So the cosine of the angle between these vectors associated with their coordinates. You can then also compare the cosine similarity across different word pairs to get a sense of their relative similarities. So we would expect in an embedding space to see a higher similarity between the words rich and wealth than the words, say, wealth and posh, just for example. The issue with a two-dimensional embedding space, though, is that given the complexity of language, the two dimensions are probably unlikely to capture many of the important nuances that underpin word meanings. So ideally, we want to embed our words in a vector space that has much higher dimensionality, so we can better represent how one word relates to another across multiple dimensions. And n dimensions is obviously a little bit more difficult to visualize and conceptualize, but what's really nice about this approach is that we can still use our cosine similarity and calculate angles between vectors of words in any dimension of space in a very similar way. So there's a fair bit more methodological detail about word2vec, but given that there's quite a bit to get through in the paper, I thought I would leave any other more methodological discussion to the end if people are interested. One thing that I just did want to highlight, though, was in preparing this talk, I came across this really nice illustrated word2vec blog that I personally found incredibly helpful. So if you're interested more, I do recommend having a look.
Sorry, Penny,
Yeah.
just to jump in. So like regarding that dimensionality question which came up, I think Danny posted that. So I think it has to do with the size of the hidden layer in that shallow neural network. So I think like based on how many units you put in that particular layer, which is in between the inputs and the outputs. So that essentially defines the number of the n, which is the n in the n-dimensional embedding.
But that's a choice?
Like yeah, that's a hyperparameter that we need to. So, so usually like people, start with 25, then 50, 100, and then 300 seems to be the most. I think it's like a trade-off between complexity and compute. So wanted to mention that.
Very good. Thank you.
Yeah, no worries.
One final bit of background I wanted to mention before I go on to the main paper is that representing words at vectors allows you to do a number of other cool things. So in particular, one of the key reasons that the word tovec algorithm received so much attention was that it allows us to do vector style operations to arrive at notions of what's known as analogous reasoning. So the classic example, which you've no doubt seen before, is the standard analogical reasoning question. Man is to king as woman is to, and if we pose this question to our word tovec model, what we can do is take the vector for king, add the vector for the word woman, and subtract the vector for the word man, and then ask our model to find the word with the vector closest to the resulting sum. And what's cool and really essentially made word tovec more or less as famous as and influential as it is today is the fact that when trained with enough text, it tends to give you the vector associated with the word queen. Now, some examples work better than others, and there's been a lot of research on this. But I just thought I'd highlight this because the paper that I will talk about makes use of this logic quite a bit. So now that we've covered off the basic bits of background stuff, we can get on to discussing the paper, The Geometry of Culture, Analyzing the Meanings of Class Through Word Embeddings. And the paper essentially argues that social class is a complex and multidimensional concept. And when people, sociologists and so on, describe what is meant by social class, they often make reference to a number of different things, such as affluence, education, occupation, status, gender, and so on. And the sociologists on the call can correct me if I'm wrong, but generally, it seems to be that whilst scholars in the sociological literature have analysed social class along these different dimensions, with affluence tending to be one that's the most dominant, the authors of this paper contend that there has been fairly limited empirical analysis on the precise ways in which the dimensions of class relate to each other, and in particular, how these interrelations have evolved over time. So this paper focuses on the evolution of social class in the US and proposes to address this question by applying word embedding models to analyze Google News text and Google Ngrams text from books published over the 20th century. And the really interesting methodological question that this paper speaks to is about how you can analyze cultural dimensions from text data. So going back to this analogous reasoning example that I mentioned, one way to interpret this woman minus man vector term, if you like, is as a gender dimension. So that is, if you take the vector for woman and subtract the vector for the word man, what you end up with is a vector pointing in a direction that is correlated with some notion of femininity. So in our vector space, if we start at the position occupied by the word king and we take a step, if you like, in the direction along this femininity direction, you end up somewhere close in this location in our vector space to the word queen. Okay. Now that's a nice example, and what these authors of this paper argue is that, well, you could do that with any kind of construct that you like, if you have appropriate word antonym pairs. So for example, to construct an affluence dimension, you could take the vector for the word rich, subtract the vector for the word associated with poor, and test this out by taking something like the vector for the word hockey and asking, what is hockey plus one step in the direction of greater affluence? Does anyone have any guesses? No?
Is it golf?
Well, they, not quite, but we'll get to golf. They tested this with using Google News text for this example, and what they ended up was the word lacrosse. So hockey plus a bit richer gives you lacrosse. Now, one issue with this, of course, is like, well, rich, poor is one example of antonym word pairs that would be aligned with, let's call it affluence, but there's lots of other possibilities we might consider, such as priceless minus worthless, expensive minus inexpensive, and so on. So what they do is they make a list of all the possible words that would align with this affluence spectrum, and then they essentially make these subtractions and take the average. So your resulting vector is a sort of, let's call it a more robust, if you like, dimension that takes into account all these word pairs. And when they do this, what's quite cool is you can then look at the projection of any word in your corpus that you like onto this dimension that you've constructed. So here in the paper, they have this lovely figure where you can see you can see the word golf, and golf is projecting most strongly onto the rich dimension, whereas you've got things like boxing and camping that are projecting much more strongly onto the poor dimension. But why, of course,
ask you one thing?
Yeah, yes.
What I'm never sure about in these models is how they capture sarcasm or the like. So when you say, oh, he is so smart, but you mean, what an idiot, right? So, yeah.
Yeah, it's a great question. I actually haven't seen a paper analyze, sarcasm, but it would be really interesting to look at this. And I'm sure you could, whether words that are used in sarcastic context more than others are, less accurate in the word embedding models that vectors that we find. It's a great, Satya, I don't know if you have any thoughts like with Bert or Elmo, because they can capture context more, whether they perform better at sarcasm.
Yeah, I mean, sarcasm detection is still quite an open question, I think, as an NLP task in itself. Yeah, but with transformer-based models like BERT, they definitely not just because a word, tovec, and a glove and these vectors are quite static, like in the sense that once you have trained them, they don't really change with respect to what sentence you're being used. So,
yeah.
So with those kind of models, we are passing the entire text through the model. So in a sense that it gets the left and right context, and then maybe depending on what other people have responded to, oh, he's so smart, for example. So yeah, it might, hopefully it, there is like actually some evidence that it does capture that kind of notion of sarcasm.
There's some, like, so where it is explicit is often in Twitter. So Simon Ricketts, one of our honours students in SOTA this year, had some nice advances with trying to capture sarcasm, because in Twitter often people use an emoji to indicate an inversion of meaning. So like his signature case was like, this is so interesting, or this is so interesting with an upturned smile. actually that all just gets encoded. And so when you see the upturned smile, you know that basically it's an inversion of the meaning of what's just being said. So when it seems like actually the problem with sarcasm is in written text, you have a missing information. It's like an omitted variable, which is the inflection in the voice. In Twitter, you don't have access to that. So we've come up with emojis to provide that kind of inflection. And that's awesome because then you can train on like this larger vocabulary. So there's actually people, I listened to a podcast once about emojis, and there's an emoji like standards group, and they have to decide what is a valid emoji and major food groups and make sure it's culturally relevant and all that. And their initial vision and the whole idea of it for them, like their passion, is giving humans a greater tapestry on which to communicate and express, which is exactly this kind of nuance in human communication, which you can kind of get sometimes in what we consider cheap talk on Twitter, is actually like somehow more rich, more richly conveyed than sometimes our text, which it's harder to pick up unless it's a spoken word. So we should all tweet our papers, maybe.
I have a question. Is this based on any particular country, society?
This paper is based largely on text for the US. Yeah, it'd be fascinating to base it on text from other languages and so on.
Yes, Marco was referring to soccer, right? Which is usually considered like a
Yeah.
Like, but I guess in the US, right, it's all the soccer moms. So with the minivan, so I guess it's more of like an upper class sport.
I haven't seen the field in Italy. That's why. So like, this is not definitely for rich, but that makes sense.
Somewhat related to the sarcasm discussion. I mean, this might become relevant when people, for example, you have a text corpus from newspapers, and if each text piece is not really classified, we have basically just a dump between, like in the best case, let's say news article and an opinion piece. Now, I like with David, because he's smiling, I mean, we ran into this issue with GDELT, where it's not just a news piece and an opinion piece, but also a movie review, for example. And then when you look at assassinations, for example, and you want to identify true assassinations, and then you dig into the data and suddenly it's a movie review, and they classify it as an assassination that might have happened in Hollywood or something because it's a movie review or something. So, but more in general, I mean, of course it depends on the task at hand, but is there a way to, you know, if you don't have a classification between it's a news thing versus an opinion piece, that, you know, similar to identifying sarcasm, that you identify a news report to an opinion, or just being able to distinguish.
There is this thing called like long-term dependency. So the further you go back in the text from where you are, for example, and the larger the window is, the more it can encode information about, okay, was this made in a sarcastic context, or like Hollywood could be like way far off than the word assassination, or that movie might appear in something like that, like actor, actresses, and so forth. So yeah, the notion of that long-term relationships could be encoded is I think one, yeah, it's a very useful tool. And those transformer models, again, they greatly help in that regard. And so does tovec, and yeah, it does capture like to a certain degree.
That's the issue with GDELT, right? It's dictionary based mainly, so
Right.
so that's why these mistakes happen easier.
One of the things that we'll get to in this paper is they do test different word embeddings based on just news text, or just based on like the book publications of Google Ngrams, and just show differences and how it does matter what text you train your model. But I'll come to that. As I was saying, you know, yes, we can do this for one dimension, but we could do this for many dimensions, and have a look at how particular words are projecting differently onto all these dimensions that we are constructing. So what's nice, for example, here, as you can see, like softball is projecting both strongly onto a rich dimension and also more feminine compared to, say, boxing is not only poor, but also projecting into the masculine dimension. So it's all quite nice in that these kind of things align with our intuition, but I think one of the particularly cool things about this paper is they do go to some length to try and validate their approach, to show that it's objectively mapping onto some notions of kind of class dimensions that you can kind of point to. So they do two things. The first thing is they try and get like a present day validation by undertaking a survey of almost 400 respondents on Amazon Mechanical Turk. And what they do is they try to validate three key dimensions: class, race, and gender, by essentially asking these respondents on Mechanical Turk, on a scale from 0 to 100, with 0 representing, say, very working class and 100 representing very upper class, how would you rate a steak? And it's amazing what you can get paid to do on Amazon Mechanical Turk. But they did this for all these different words here, falling under all these different categories of cultural things. And then what they do is look at how their survey ratings compare to the projection of a given word onto the cultural dimension that they construct using these different antonym pairs for affluence, gender, and race. So here's one of their plots, which I think shows this quite nicely. Here, the black text relates to the ratings according to the Amazon Turk survey. The white or grey text relates to the projections based on the word embedding model. And what you can see is, like, for the word opera, both in the survey and the word embedding model, the word opera is associated more strongly in the kind of rich direction, and also in the white direction of race. Yeah, there is some deviation that you can see where the word embedding model rates opera a little bit more white and a little bit less rich compared to the Amazon survey. It's quite fun to have a look at this. You can see kind of similar things with rap and so on. But there are some words where you can see quite large deviations, right? So for the word jazz, the embedding model, interestingly, rates jazz much more rich in its associations than the Amazon Turk survey. So to get an overall sense of how close word embedding models are aligning with the survey, overall, they kind of look at the Pearson correlations between the projections on each dimension associated with the word embedding and the survey. And what's interesting, as I sort of highlighted earlier, is that the results are differing when you use different text to train the word embedding model. So if you're using Google Ngram's word tovec embedding, you'll see that while it's reasonably high in the correlation for class and gender, race comes out as fairly low. In contrast, if you're using news text, you've got a much higher correlation with the race dimension. And they also test Common Crawl, which is mainly website text, using Glove embedding, which is a slightly different word embedding model. And this has sort of a lower projection with race again. So why? Yes.
Oh, you're about to probably go into it. The ethnicity and background of the digital Turk, Mechanical Turk people versus...
that's a good question. From my reading of the paper, I don't know if they...
Because I would assume 90% are in Bangalore.
It's possible. I think they may have described the survey respondents in some SI or appendix that I skimmed over.
Satya, do you know what that's my colloquial kind of thought, is that there's a lot of people from, subcontinent, etc., who are involved in Mechanical Turk, but presumably it's become a more general occupation.
I think you can specify what kind of distribution you want your
in
respondents
geography
to
or
be.
so on. Yeah.
Yeah.
Because I mean, to Marco's point or the conversation before, if we asked an Italian group versus a, Brazilian versus a, Indian versus a Chinese group, they might be quite divergent.
Yeah, no, absolutely. The two reasons that the paper gives for why the race thing isn't aligning so closely is firstly because with the Google Ngrams text, they argue a lot of it is scientific publications, non-fiction that may not have strong racial associations as you would see with news text. The other reason they give is that because you're using words black-white or black minus white, there is quite a strong probability that actually the word embedding is tapping into color rather than race. And so you've got some issues with that. So in any case, due to this poor alignment, they actually throw out their race dimension and don't use it in their analysis.
I just have a question. Would it have been possible to add black plus man and then subtract from white plus man or woman or human, for example? Because I assume,
so.
right, like all the algebra is consistent.
Yes.
So yeah, so like rather than just adding and subtracting a single token, maybe we could do some composites and.
Absolutely, absolutely.
Mm-hmm, yeah. Thank you.
It's a good idea.
I mean, that's the beauty of the vector representation. You've got all this algebra at your fingertips, which is very cool. Mm-hmm. Okay, so the second bit of validation that they did was, since they're saying, we're looking at over the entire 20th century, we better do some historical validation based on a historical survey. So they pulled this paper out from a 1958 study called An Atlas of Semantic Profiles for 360 Words. And this paper essentially does a very similar thing to what was done on the Amazon Turk survey, where they had 20 different scales or dimensions defined by antonym word pairs. In this case, they've got things like cruel, kind, curved, straight, masculine, feminine. And they asked college students to rate 360 words along each of these scales. So it's interesting. I mean, the word abortion, you can see rates quite low on the first dimension, which is cruel, kind, indicating that, 1958 actually in college students, abortion was seen as much more cruel. It would be interesting to kind of do this analysis again and see how things have changed. But anyway, taking these ratings from this historical paper, they then just train a word embedding model on Google Ngrams text from 1950 to 1959, and then look at the correlations in these dimensions. And what you can see is actually it does pretty well. They find statistically significantly positive correlations along all 20 scales, with some dimensions like kind, cruel, good, bad, masculine, feminine being impressively high. Okay, so having gone to quite some length to show that this word embedding is able to capture constructs in a way that does align with surveyed respondents' views and perspectives, both today and the 1950s, they only then turn to really analyzing class and the kind of interrelation and evolution of these class constructs. So what they do is they construct 7 different class dimensions. They use the affluence and gender ones that I mentioned. They throw out race, and they include 5 more based on cultivation, employment, education, status, and morality. And then to explore how these dimensions are changing over time, they train separate embedding models on each decade of Google Ngrams text to explore the evolution of cosine similarities between each construct and all the other constructs over time. So in this plot, what we're focusing on is the affluence dimension here. So think rich minus poor. And you can see, for example, in 1900, what we're seeing is that from the word embedding model trained only on the 1900 to 1910 text, we're saying, what is the cosine similarity between affluence and, say, cultivation, well, relative to say gender or education, it's actually quite high, suggesting that words associated with higher affluence are more closely aligned with the cultivation dimension than gender or education, at least in that point in time. But as you can see, by 1990, the education dimension is now the most closely aligned with the affluence dimension, suggesting that at least in our Google Ngrams text, the way that affluence and education are construed has become more closely associated over time. They then argue that, you know, it might be possible that the evolution between affluence and education is mediated to some extent by notions of cultivation. So you can see that cultivation is defined by these sorts of word antonym pairs. So at one end, you've got things like cultured, polite, civil. On the other end, you've got uncultured, rude, and uncivil. And the authors state that cultural capital scholars have, in the literature, long argued that education reproduces patterns of economic stratification by, to some extent, providing students with cultural knowledge and dispositions that, to some extent, exert like signaling effects in the market. So what this would mean in embedding terms is that words that project strongly onto the educational dimension only have an association with influence insofar as they also project strongly onto the cultivation dimension. So to test this, they construct an OLS regression model based on, they take the 50,000 most common words in each decade and their associated projections on each dimension. I have to say it's a little bit light in detail on exactly the regression that they run. They don't have a table or anything, they've just got this plot. But I assume that the dotted red line is the coefficient on the correlation between education and affluence. And then the solid red line is the coefficient once you also include the cultivation dimension as an additional regressor. And what's interesting is that if you control, if you like, for cultivation in this way, you can see that prior to 1960, the coefficient on education is actually negative. So what this suggests is that if you have two words that had the same projection onto the cultivation dimension, but one word projects slightly higher on the education dimension, then prior to 1960, this would actually have in the text a more negative association with the affluence dimension. Now, it would have been really nice if the paper provided some actual words to show this example, but unfortunately they don't do that. But what they do is suggest that this could be because at the beginning of the 20th century, getting an education meant that actually, you poor thing, you had to participate in the world of work rather than just living comfortably on rentier income. So in any case, for better or worse, things have changed quite a bit since then, as you can see. Here are the plots for all the other dimensions. You can see that gender and employment have a cosine similarity quite close to 0 for most dimensions, suggesting that they're actually relatively orthogonal constructs in this vector space, whereas other constructs show a bit more interrelation and variation over time. That said, one thing that the authors really emphasize is how remarkable it is to see such stability across these social class dimensions. Now, they don't kind of make mention of what they would expect to see, what's the appropriate null, for example, of how much variation you would expect to see, given that language is fairly stable. But it is interesting to see the stability when you look at the change within dimensions over time. So here, what the authors are looking at is how the correlation of a given dimension changes with itself over subsequent years. So to explain these plots, because I found them fairly cryptic. What they're doing is they're taking the most common 50,000 words, and then the point on this line, I assume you can see my cursor, is representing the correlation between the word's projection onto the affluence dimension for the decade of 1900, 1910, whereas the next point along the line is the correlation for 1900 to 1920, then 1900, 1930, and so on, all the way to 1900 to 1990s. And you can see that over time, it's not that surprising to see they're becoming less and less correlated as things are changing. But the authors do make a point of noting that, you know, as they say, this pattern reveals that beneath the historic stability of classes' dimensional structure, there is continuous flux in how cultural markers are positioned along this spectra. So this immediately leads you to wonder, well, how these specific words are changing underneath these spectra. Like, what are the words that are moving around for each of the spectrums? And unfortunately, they only show you the results for one dimension. It would be really cool to see, you know, changing words along all their 7 dimensions. But what you can see, at least for the employment dimension that they show, is that in 1900, you've got words such as lords, governor, mayor, earl, bishop, secretary, which originally projects quite highly onto the employer dimension and reducing in their projection by 1990, whilst you've got other words like speculators, promoters, mogul, designers that were less closely associated with the word employer at the start of the century, and by the end of the century are much strongly projecting in this direction. There are some odd things going on now, and this perhaps is speaking to why they didn't, you know, surely completely show what's going on under the hood for all these dimensions. You can see there are some peculiar words, like you've got patient and expectancy, that aren't things that you would really expect to be associated with you know, employee types of contexts. But they just sort of suggest that you know, some of these ambiguous findings provide what they say an instructive example of how inductive approaches must be applied cautiously to word embedding analyses. So, you know, not everything is super watertight once you do look under the hood, but in the majority of words that they show, they seem to be kind of traveling in the right kinds of directions. So just to wrap up with some brief takeaways, I hope you've seen how word embedding models can offer novel ways to explore and analyze semantic relationships and notions of meaning, at least in the kind of distributional sense. Here we've really only focused on the word tovec model, but as you know, Satya and others have mentioned, there are a number of others that have been developed more recently and are good for capturing different things. I think overall the paper does a pretty nice job of demonstrating how these approaches can be quite useful for analyzing multidimensional concepts such as social class, and providing a methodology for constructing dimensions of interest through antonym word pairs. But of course, the methodology is completely general, and so it can be applied to all sorts of other things, which is what kind of got Simon and myself and Laura in particular quite excited. And the other nice thing about this paper is that they do go to some lengths to validate their methodology. And as we have found already, it's quite fun to look at what pops out of these word embedding models, but it's another thing to try and really validate it and show as scientifically as possible that, you know, the word embedding models are aligning with something that's more objective. Did I lose you? Am I back?
No, you're there.
Oh, good.
We lost your presentation.
All right, that's the end of my presentation. Okay, that's fine. I got to the end in any case.
As in it, yeah. I have a question, Penny. Do you think that one interpretation of their results could be that although we might think that culture has changed, the writers, it's like who owns history is the writers of history, that the writers of words haven't changed. So
yeah,
I would be really interested to see if kind of like insurgent or disruptive text spaces, I don't know what that is. I hasten to say it's like Reddit or something, but wherever text is being created by marginalized voices, it'd be really interesting to get a bag of that and then compare that to kind of formal spaces and look at the gaps, you know, over time or whatever, and see if there's actually like closing, you know, is there learning between them and so on.
Yeah, that would be fascinating. Absolutely. I mean, even just to see how different the vectors are for particular words and then see, yeah.
Yeah.
A great idea.
It's almost like you want to get like you want to eavesdrop on audio in like the train carriage, what people are actually talking about, and when they use the words, what they're talking about. Like if you take the text that's been generated, like the audio in, I don't know, Harlem or I don't know, somewhere like, you know, the Bronx or whatever, and then you look at what people are writing about, like in the New York Times, I suspect we're dealing with pretty different, like textual universe. And so I mean, it's like, you know, rules and institutions only exist in people's heads, right? It's like the kingdom of beliefs. Culture is kind of like, you know, it's like what we think is actually what's going on in our heads. And we read things, but we read things and we feel dissonance when we're like, no, you don't understand, or that's not my culture, or no, you don't, you know, like, oh yeah, no, that's it. You've put down what I'm thinking. But that's like a crystallization of what we think is actually true. And sometimes we get impacted by that. So I wonder if there's a way of, we need more alternative data.
Even, I mean, audio is interesting because I think we talk very differently, right? And whether that difference is captured or not, like whether it's close, the close enough, because they're still aligning or not, just because it's a different medium, would be also interesting to explore.
Sasha, have you thought about that at all in terms of your written histories work? Oh, here we go.
No, I mean, the very long run stuff is always complicated over decades. Meanings change so much. But you made a point that I also found fascinating, which is, where do people communicate in a written style at all? So, and what do newspapers capture and all that, right? So, because even if some high school kid from the Bronx was ever to send a letter to the New York Times, it would surely be edited, right? And it wouldn't use the words the kid would use on the street. Yeah? And I think on the one hand, we have echo chambers, and there is a lot of research on that, but I think there is also linguistic chambers where people that talk in a certain way now talk to each other in a closed space. And that's why I posted this paper by my sociology co-author, PhD student, with this exciting title, How Chicago Gangs Interact on Facebook, which probably wouldn't be captured by the Google Ngram stuff, right?
Yeah, I just thought, since Simon mentioned Harlem and like audio tapes, so I also thought if you would look at, like, I don't know, posters or graffiti or so over time, right? Or pictures of like what was written on the walls, which might be like a better representation what is going on under the hood, at least in a, but then you also got the right urban versus countryside. But I think this would be a way more unfiltered kind of.
It's a cool potential image application of Google Street View. So imagine if you you acquired text, graffiti text. So you have to throw out all the signs, like everything that's just like, you know, official. But if you could pull out text from walls that's captured and then do it from, you know, you'd have geospatial, you'd be able to do, just even in one point in time, a geospatial comparison between the text used and, you know, on these sort of dimensions would give you a pretty interesting window, this sort of unfiltered window. Matt Olkers would be the expert domain author there.
Yeah.
Urban
And whether
graffiti.
the frequency of swear words, there's anything about socioeconomic
Well, it'd be, I don't think that's going to be an easy task, right? I mean, because part of it's going to be tags and they're going to be like, I mean, can you imagine trying to pass the darn letters out of those things? But then there's going to be political things like, you know, it's like the back of the toilet stuff. Yeah, I went to a block of toilets in Bowen, Upper Bowen Reservoir recently, which I reckon hadn't been used for probably like, you know, 8 months. And it struck me, yeah, it was like a bit of a time capsule, what people had written on the walls there and their concerns. And it's not language that you see very much in the Big Smoke. So, yeah.
And that's interesting. Like the writing style in the graffiti, it's so unlike any natural writing that it's more art than actual, you know, how humans write. So I'm thinking, so there's another field in which people are trying to break captchas using like neural nets, and which is, it turns out is extremely hard. I mean, that's why we have captchas in the first place that asks you, I'm not a robot, and you know, no automated service can break that. But now we are at an inflection point apparently. So there are like models out there which can break that. So I'm thinking like it's more, I think the distribution is much more closer to captchas than maybe, any other natural text.
There was one graffiti that I don't know if anyone else saw, but a few years ago on the bus linking from Huntingdale Station to Monash. There's a long line that is always built. It used to be before they put the shuttles in, so you used to stand there looking at the wall. And they had this long, simple, black on concrete sentence which said, "There's no emoticon for existential despair." I thought it was the greatest piece of graffiti in front of like Monash incoming students. Unadorned, no artwork. That was it. And then like about 6 months later, it had been scrubbed off. I thought it was pure vandalism. Yeah. Anyway.
Yeah, I like graffiti, I would imagine is super tough because every artist has its own style, and the point is to be not as legible as normal writings. But what I also thought, speaking of graffiti, I mean, you have pictures, right, of pop culture figures or underlying, right? So this would probably be easier to like get the face. I don't know if there's everywhere is Tupac or Biggie painted on the walls, right? That tells you a bit about the underlying movement or the ideology about these areas, right? Or I don't know, back in the days, Che Guevara, or even nowadays, right? So you could maybe trace over history just by the pictures that you have on the wall. You could probably over time even look at maybe ideological movement. It's obviously like probably a small group that does those, but I figure it's like a symptom of what is going on in the culture and the background. But yeah, anyways.
mapping the shadow of Che, 3 decades of political art and the rise and fall of socialism.
We already have a title at least.
Yep. I love it.
Oh, it's good. So good. Really interesting. Oh, thank you, Benny.
Thank you so much, Benny. That was very good.
Oh, pleasure.
It was really great presentation.
Very interesting.
When's next, David? Is there another one?
There is another one in December. I have to admit, I forgot the date. I think it's the 5th of December, but I could be wrong. It's early December. So there's another one. Ola will be doing, I think, something about synthetic control methods. I think she's
Cool.
covering the Shu political analysis paper about the generalized synthetic control methods. So also, yeah, tune in again. Will be again an interesting presentation. Thanks so much, everybody, for joining. And yes.
Bye-bye.
Thanks,
Thanks,
Penny.
David.
Thanks, David.
Thank
See ya.
you.
Thanks so much.